In this video I show you how to calculate the reliability of different scores. Let's say you have a pre-post design, you measure a variable at the first time point, then maybe there's some kind of intervention, and you measure the same construct at the second time point. If you do that, and it's not a single item, but a scale, you need to estimate the reliability of this change score. All calculations in this tutorial are based on this example dataset. So we have 3 items and 2 time points. So each item is measured at the first time point and at the second time point. And for a different score, we would calculate the scale for the first time point and for the second time point, and then subtract the first time point scale value from the second time point value. The first option I'm seeing from time to time is just calculating the reliability for each time point. If you do that, you would get a Cronbach's alpha of 0.90 for the first time point and 0.60 for the second time point. However, that is not what we want to know. We want to know the reliability of the change score, not of the 2 scores for the different time points. So this is not a good option. The second possibility, there is a classical formula. These are the reliabilities per time point. This is the correlation between the scale values of both time points. And S and S squared are standard deviation and variance. And we could plug in all the values in this formula and get an estimate for the change score reliability. I've done this with our example data, resulting in a reliability of 0.61. The problem with this classical formula is, in most cases, it will lead to an underestimation of the true reliability. For that reason, my recommendation is using another method. That is, calculate the reliability of item difference scores. So instead of calculating the scale for the first time point and the scale for the second time point and then subtracting them from each other, here we do it the other way around. First, we calculate difference scores for each item, and then we calculate the scale from these item difference scores. It will lead to the same overall difference score. But if you do it this way, now you can simply calculate the reliability, Cronbach's alpha, using those item difference scores. You can simply plug those item difference scores into the formula for Cronbach's alpha with your statistical program. And in this case, we get a reliability of 0.66. And this should much closer match the true reliability than this classical formula I showed you earlier. If you need a citation for this method, I recommend reading Gu et al. 2021. Thanks for watching and see you in the next video.